All right. Good morning, good afternoon, good evening, everyone, wherever you are from. Welcome to Webinar Wednesdays, the Chemical Engineering panel. My name is Bree Yancey. I'm the Communications Coordinator for the Graduate School. And here we have Molly.
Hi, everybody. I am Molly Desimone. I'm the Graduate Admissions Coordinator. So most of the emails that you've been getting from me are sorry about that for the overload. But if you have any questions regarding admissions or your application, please feel free to ask at the end.
Yes. And then here we have Dr. Hema Ramsurn. She is Associate Professor of Chemical Engineering and the Graduate Advisor. So once you get started and you apply and you are accepted and you enroll, Dr. Ramsurn will be your contact for making sure that your classes are all in order, that you're set to graduate. If you have any questions for just your program in general, she is the one to reach out to. And she has a wonderful presentation for us today about chemical engineering and our programs. So I will give it over to Dr. Ramsurn and enjoy. Oh, I think you're muted.
Can everybody see my presentation?
Yep, I can.
Okay, and you can hear me too?
Yes.
All right, okay. So let's minimize this. All right, so as Bree said, I am the graduate program advisor for schools for chemical engineering. And if you have questions, you can wait at the end or put them in the chat. I can't see the chat, but probably Bree can, and she can tell me the questions while I'm presenting. Just feel free to stop me anytime, raise your hand, ask a question or something. I'm fine with it. It's a very brief and not formal presentation, just to give you an idea of what we expect of students that are trying to come and do graduate school and graduate programs in chemical engineering. All right, so you probably know this. I just put it down here. You're expected to do all of these things to be considered for graduate admission. The graduate school has a website and it has the application links all over there. You have to have a statement of purpose. The letters of recommendation are important. That's why I put them in red, because we read them. The professors read them, especially if you've done research before with any advisor as an undergrad or as a master's student, or you've worked with somebody, they are testifying on what kind of a person you are. So we actually do read those letters, so they are important. Of course, you have to have a GPA of at least 3. Your GRE score should be around 300 or more. You have to pay the application fee. And then if you're an international student, you have to also have English proficiency results. So these are the items that are submitted. Now, some people apply for a waiver for English or for GRE. So depending on the case-by-case basis, we may grant them or not, but it depends on where the student comes from. Usually for international student, we like to have an English proficiency test, just because we want to make sure that the student understands us and we understand them. So we recommend the TOEFL, and usually we don't waive it unless you already have an undergrad from English-speaking countries, especially if you're from the US or UK or something like this, or you have another testimony of your English proficiency. So things like that. So there are 3 degree options for chemical engineering. For the chemical engineering degree program, we have the Masters of Science in Engineering, the first one, which is the MSc that you see right there. You need to do a research project with a thesis, so you have to have a minimum of 6 credits for that. And usually people that get an MSc usually work in the industry, and they just want to upgrade their undergrad to a master's degree. So it does require thesis though. So you have to do research in this MSc. Then there's the other masters, the Master of Engineering, which has no requirement for thesis. You just have a project that you do. It's usually a little bit less stringent when it's compared to a research project, but you still have a project to do. And it's usually a lot of times non-chemical engineers take this master's just because they now can become familiar with a different field. Now, you still have to be kind of a scientist to apply for this. We have a lot of chemistry major undergrads that actually apply for MEs because we're very close in terms of in terms of some of the basis of science is the same, like chemistry, and they do some thermo, so some of things can be waived and things like that. So a lot of chemistry undergrads apply for the masters. So and then of course there's the PhD program, and usually it's a heavier load. It's of course a lot more credit hours, a lot more research hours, and this is for students that want to become a doctor at the end, and they want to study and do research in a particular field and area and very in depth. So it takes around 4 to 5 years to complete that degree. So in the department, we have, this is just an example that I'm showing you. We have an internal document to keep you on track of all these research credit, all the credit hours that you require. So I make the students fill out these forms. I tell them to fill this out. I send this to them at the beginning when they enroll their first year, when they're the first semester, and they start filling this on their own. Like, we have, as you can see, we have 4 core courses right here, which you need to complete. And then there's some electives that you need to fill. There's a 1 math class that you all need to take. And then the rest is just any 7,000, 6,000 level classes that you find or that you're interested in. And when you're choosing these courses, it's usually talking to your research advisor, because the research advisor will tell you, okay, I want you to focus on research this semester. So we'll get 6 credit hours of research and you can do 1 class, because you still have to complete all your class requirements, your course requirements. But you need to talk with your advisor. Do not just enroll in classes like that. You have to talk to your research advisor with whom you're doing research, so that you guys are all on the same page. And also when you are and you have to always be, be very cognizant of how many credit hours you're taking, to make sure that, at the end of 4 years, oh my gosh, I just now miss a math class, because if you see here, it's minimum of 6 credit hours. So you have to take a minimum of 6 credit hours in math. So you make sure that you have 6 credit hours of math. And that's why we give this to you, so that you can total this and make sure that you are in the right track. All right. So that's just for the PhD internal document, but we have the same thing for masters that I give to the students that do masters. So this is the timeline for a doctoral degree. Master's is usually 1.5 to 2 years, depending on the courses that you're taking in your research project. But a doctoral student usually has to do a preliminary research exam in the 3rd or 4th semester of when they have started to enroll. We used to have a qualifying exam that they used to sit down and take. We've now replaced it with this preliminary research exam. And it's basically, you are presenting to the committee. You will constitute a committee. Your professor will be your chair, and you're going to present on what you are intending to do in your research. And then you will defend your proposal in the 4th or 5th semester, because now you have a better idea of what you are doing, because you've been approved for the idea in the preliminary research. So now you defend your idea with a little bit of data, so to show that, yes, I'm on this path. And of course, the final defense is usually in the 4th or 5th year. And then you become a doctor, right? So I know people always ask about funding. So there are two main things to get funded. First, you have to have funds. If the department and the professors have funding available, but they also choose based on your application package. So the first thing to do is to submit your application, complete it as much as possible, because if it's not completed, I cannot send it to the other professors. Once you are admitted to chemical engineering, then I usually circulate the packages of all the students that have been admitted to all the professors, and then they take a look, and if they are interested in a student or they want to talk to the student, they will then contact you. However, you can also contact the faculty directly by email to inquire about funding option. That's not a problem. So if you think you want to work with a certain professor because their research is what you want to work on, go ahead and email that professor and ask them if they have a space in their lab, if they have funding available, and things like that. If you haven't applied yet, they will ask you to apply first. But if you've already applied, you can attach your resume or even your package and say, okay, I've already applied and been admitted, and I would like to work in your group, and I was wanting to know if you had any funding available. So usually the professors go through all the students' packages, and if they find a match, I mean, they like the students' package, they like the students' scores, it can be a lot of things. Different faculty look for different things, but a strong application is what they're looking for. And if they're interested in a particular student, they usually contact them. If you have a master's, I forgot to say, you also are allowed to transfer at least 30 credits of the master's, usually just A's and, no, not usually, only A's and B's are transferable to your PhD program. So you don't have to start from scratch. You already have 30 credits in your bank. That also plays in your role. Sometimes having masters helps with the decision, but some professors don't really they don't really care if you have a master's or not, as long as your package is good, you have done research. Even if you haven't done research, that's okay. So usually if you're given an assistantships, it covers your tuition and your stipend. And I'm saying typically at least $18,000 per year, because that's the minimum that we usually offer for teaching assistantships. But a lot of times it could be higher, especially if the funds come from a different source of funding, either industry or government or any other, they have other fund sources that they have. So as I said, the funding amount depends on the funding source. So, but you'll have a livable wage so that you can be able to, you'll be able to work and meet all your needs based on the tuition provided. I mean, the stipend provided to you. So I'm going to go through the different professors and what are their areas of expertise. I don't know a lot of details about the area of expertise. I just know a general view. So if you're interested in any of those particular ones, feel free to email the professor directly. Usually, I mean, it's not frowned upon. If the professor doesn't reply, because that could happen, that means they may not have time or something, or they're not taking any student, but that's okay. You can always try. It's okay to email the professors directly. So this is Dr. Crunkleton. He is also our dean. He's a chemical engineering faculty. He's a professor, but he's also the senior associate dean of the College of Engineering. And he's a fluid dynamics guy. He does do a lot of modeling and simulation in all sorts of areas. He has done a lot of modeling and simulation in fluid mechanics and alternative energy. So he's a computational guy. So if you are into computational modeling and simulation, Dr. Crunkleton may be a match for you. The other professor that works in our department is Associate Professor Daraboina. So Dr. Daraboina works in both renewable and non-renewable energy sector. So he works in flow assurance, so looking at pipe flow, wax, how is wax affecting flow in the pipe on the oil field, so very practical. A lot of his funding comes from industry, so his students usually work directly with industry. They have to present their data to industry, so if this is something that you like to do, then Professor Doroboina could be a match for you. So, but he also works in environmental issues. He works on CO2 capture. He works on water desalination and hydrogen storage, natural gas hydrates. So he has a variety of things that he works on. And he has a big research group. I think he has the biggest research group in our department because he works in two very distinct areas, and industry, and then also in environmental issues. If you are interested to work with Dr. Doroboina, you just go on our website, the emails are there, just click on the email, send him a message to see if he's interested. But you will have to first apply before the professors even consider you, so you have to apply through graduate school first. And then there's Dr. Ford. She works on delayed coking, which is industry based. So her funding comes from industry, and she usually looks at how the delayed coker products can be reused multiple times, cracking multiple times. She looks at how coke can be used, how this process right here can be optimized. And so it's all based on refinery processes. And we have we have a TU main campus. We also have North Campus. Dr. Doroboina and Dr. Ford also have like equipment down there, because the scale is pretty big. It's not lab scale, it's actually pilot plant scale equipment. So you have to run these experiments on pilot scales, which is pretty cool. So they work on the kinetics of fouling, kinetics of foaming, cooling, looking at the coke morphology and things like that. So if this is something that's interesting in you, that's very chemical engineering kind of research. So our department chair, Dr. Johannes, works in algae and carbon capture, two main fields. Engineer. He basically does DNA modification, RNA modification, modify the algae so that they could produce better products, or oil, or whatever it is, right? So he's more into the genetics of the algae. So he plays with the algae. He actually grows them in the lab and then kind of grows them differently by changing their genetic footprint, and then seeing if that makes an effect on the products that they want to form from algae, be it oil or be it the biomass or whatever it is. So, and then he started working a little bit on carbon capture with Chevron. So these are his two main areas of focus. So if you're interested in those areas, you can contact Dr. Johannes. So this is me. I work in energy. Most of us do relate to energy in some way or the other, because we are all chemical engineers. I've worked, my PhD was in biofuels, so I still work in biomass, but I do bio-based materials. So we work on graphene, activated carbon, adsorbents from biomass. I've also started new projects in terms of methane conversion to hydrogen to benzene. And recently, we had a DOE funded project on carbon-carbon composite, which is actually closing this year. We've worked on it for 3 years. And it's making composite for solar receivers. So if you're interested in renewable energy or methane conversion, which is basically just non-renewable stuff. So, but energy anyway, it's catalysis, then you can email me. So the last professor we're going to talk about is Dr. Weston. He's an assistant professor in our department. So he's the newest professor. So he works in surface science and rheology. So looking at materials and their interface, looking at the study of the flow, the deformation. So really looking at the science of flow, basically, like literally how it works. Why does it behave like this? Why are the fluids behaving like this? And what's the phenomena that's actually driving this this behavior is what he looks at. So surface science and rheology is what he works on. He recently, and that's why I put this other slide, he recently got a huge grant from the National Science Foundation to buy this equipment we just installed this month. So he's still playing with this. We're getting training from him. This is a small angle X-ray scattering device. So we're very excited. The department's really excited to work with this device so that we can get more data for any of our research. Most of us can probably use this data because it will analyze structures in the nanometers and even flows. So they're actually figuring out how to make this instrument work for a lot of people, even in the region. So we're excited about this instrument. That's the department. So I'm going to leave you with the last slide where, just to let you know, these are a few things why you should think about chemical engineering degree from TU. We usually graduate students at an average of 4 to 5 years, so you don't stay here for too long, which is good, right? Because you want to go out there and work. We give you faculty give you a lot of opportunities to have leadership roles. You represent the department by being a senator on the Graduate Student Association committee. We also have an internal chemical engineering association where one of the students will be the president and one will be vice president. So it's like a leadership role, because you want to do research, but you also want to do other things. So to showcase that you have other types of skills within you, because you have to build up your resume. And because we are a small university, you work directly with your professors, and it just makes it more valuable. You also collaborate a lot with departments. For example, as you've seen that new equipment that we have, a lot of the other departments are going to come and work with Dr. Weston and with us to use that equipment. So you get to collaborate with other departments, other faculty, so that way you get other insights on your project. And you will be mentoring undergraduate students. We have a very good bunch of undergrad students that are very smart, that like to do research, and they volunteer a few hours per week to work in our lab and help our graduate students. And that's a skill that you will develop, because the faculty supervises you, but you will supervise undergraduate students. And a lot of the students present their research at conferences. Usually everything is paid for. You're sent to the conference. If you have funding, and there's also funding for graduate school, you get to, as soon as your abstract is accepted, you get to go to a conference. All my students have presented their work at conferences. I try to send to my students to at least one conference a year once they have results. And it's exciting to go at conferences to see what others do, what you are doing, to see if what you're doing is as good or if not better than others. You get more ideas when you go to conferences. You have networking facilities. So it's a great place it's a good thing to go to. And as I said, some of the projects are industry funded, so you get to work with industry people directly, and it could lead to good job prospects too. At the end, I put some recent graduates that have graduated and are working in different areas. So we have students that are working in academia. A lot of students work in industry, and with their TU PhD degree, they can work almost everywhere. Okay, so some are carbon capture, some are pharmacy, some are in materials, so some are in postdocing, some, so it depends on what you've done in your PhD. That way you get to, go there. All right, so this is all from me. So if you have any questions, I would be happy to answer them.
We had one question from Eugene asking about the 1800, well, $18,000.
18,000.
Yeah, $18,000 stipend. And does that amount exclude tuition waivers?
Yes, this is just the stipend and the tuition is separate. So a lot of times if you're given assistantship, it just depends on the funding source and what it has, but a lot of times the tuition is fully covered, or at least half or 3/4 covered. If you're given assistantship from the department, the tuition is most of the time covered, so you don't have to pay tuition.
I think there's another question here I see. What are the benefits of a PhD in chemical engineering?
Well, as I said, so first of all, you want to do a PhD if you're interested in, you are an person that's interested in, learning a particular area in a high depth. So because you are trying to find an answer to an unsolved problem, that's because this research that doesn't have an answer yet. That's why you're doing research. Now, benefits, there's a lot of benefits, as I put in my last slide, right? But the benefits of doing a PhD is if you want to have either a career in academia, if you want to become a professor, or you want to do research in big industries. A lot of our students, academia, very little, the percentage of PhDs that go to academia is pretty small compared to the rest of the PhDs that usually go into research and development industry. So they do research, but in an industry setting. So they will be in charge of a lab and will be conducting research that would be more applied. Because we're engineers, we have applied research. So it's most of the time research that's going to benefit the industry. You're trying to maybe develop a new catalyst, develop a new material, or trying to understand a process better so that you can model it or something like that. So these are the advantages of doing a PhD or advanced degree in chemical engineering.
Eugene is asking, how often do students from your school get industrial internships?
I can see that. So it's
perfect.
not, so it just depends on the funding. So I can't say how often, but every year they have funding for students that sustain. And it's not that the industry retains the student. No, that's not the issue. Sometimes, however, the industry because the industry people come to listen to the talks because they have to give a report to industry every year. So if they have developed a certain research and that industries actually have an opening, a lot of times they will make that student apply. That doesn't mean the student will get the job because it's usually an open application or the other people can apply, but you have a leg up because you've worked in that area. So that doesn't mean that they retain the students. So that's not the case. They don't retain students at all, but they can approach the student if they have an opening and or if they have a job. And how often? Well, Dr. Draboina and Dr. Ford are the ones that have industry funding, and they're always taking students. So sometimes they have funding for this year and they may take, for example, this year, Dr. Ford took like 3-4 students at the same time so next year she'll probably not have that much need because she already has new students. But you never know. Same thing for Dr. Draboina, but it's not, so it's almost every year. Oh, I see another question. So how far can you stray from your research focus when you're getting a job in industry? I'm not sure what you're saying by that, but what I'm going to answer this in general. So a lot of times when you have a PhD, you're being trained to tackle an open-ended question. And it's not like you're going to get a job in that specific area that you do research on. That's pretty rare because the area that you researched on is very, very specific. Like it's a drop in the ocean, right? So to get the exact same job doesn't work out, even if you do industry jobs, because they'll make you, they know this is your area, but they're going to do some other things as well. But your training while becoming a PhD, looking at an open-ended problem, solving it, trying to find ways to improve something or a new thing is what they are banking on when they give you a job. So you may stray a lot from what your research was actually when you did your PhD. I mean, I'm thinking about my students, like my student worked in biofuel. He's now working in carbon capture, one of my students. The other student, he started in startups in biomass, but now he's in the pharma industry. So and then a third student, he is actually working in materials and he did methane conversion. So, you know, so you stray a lot, but that's not a problem. Yes, your options are pretty wide open. Yes. But of course, a lot of times, for example, so now your options are open, but like, for example, if this industry is looking for a person that, because it's an industry that works in, I don't know, resin or something, and you have like, you are people that have worked in resins are applying, so they have a leg up on you. You can't do anything about that because that's just competition. Okay, I see. Another question, what if I have an overall GPA slightly below 3? Am I still possible to be admitted to master's? I don't want to say yes or no. It just depends on your overall package. Sometimes we will put you on probation. When you are below 3, what we all mostly do, we put you on probation. We give you an admission on probation, but it also depends on what you have in your package. So I have to look at the whole package before saying this. Sometimes I do not admit people that are below 3, but sometimes I have done this in the past. I have admitted people in the program with 3, slightly below 3, but they are usually put on probation and they will have to score at least a 3.0 GPA in the first semester, otherwise they can't continue. So there are some clauses there.
Eugene had a question earlier. Presently, a student is pursuing a PhD in analytical chemistry. Can this student transfer credits to PhD in chemical engineering?
Yes, a lot of the electives definitely can be translated for sure. Like, because you have higher level electives, we can definitely transfer those and you can knock those down. You will have to do core chemical engineering courses because you have none of those. But the electives, the ones that you've scored A and B in there and they're high level, can replace the 6,000, 7,000 level electives we have. So the short answer is yes, we can transfer some of the credits for sure. I see Eugene still typing, so I'm waiting. Is there any other question in the meantime?
I guess one, would you say that the chemical engineering field is competitive, or?
What do you mean competitive in what sense?
Would it be, well, I guess you kind of mentioned that it's wide open. Options are pretty wide open. But even if those options are wide, would it be difficult to even get your name through the door after you've graduated, you try to look for a job?
Well, I don't think so. I mean, all the students that I have graduated were international students and they have jobs. So I would say no. I think it's not, I mean, it is harder for international students to get a job in general, just because you're international students. So people have to sponsor you, your visa and things like this. But the good thing about having a PhD in a STEM related field is that there's something called the OPT, optional practical training, that you can apply for. And you can work for at least 2 or 3 years. I don't know. I don't remember the exact year and time. That's the U.S. The state of the immigration law under OPT, and it's just a very simple paperwork that you do. You don't even, once you have OPT, you don't have to have working visa, because that's like you're still a student but working in a field. So actually, my student that just graduated, he's under OPT right now, working for a firm, and then during OPT he'll do all his papers in his with his employee to move towards a green card, so that he can, if you plan to stay. But the answer to that is no, there's jobs for you. The job market right now in the United States is pretty good, very low unemployment rate, and renewable energy and energy sector in general is having a boost. And, chemical engineering is tied to energy very, very interestingly. So there are good opportunities. Eugene, you had a chemical engineering course as elective. Yeah, it will count maybe as a it will count as an elective probably. I have to look at it. I have to see your grades and everything. But it probably will count if it's like a graduate level course. If it's an undergrad course, it doesn't count.
While Eugene is typing this question, Dr. Ramsurn, do you want to give these potential students like your information or who to contact if they have any further questions or more specialized questions?
Sure. Let me type my email in the chat. Should have. Oh no, I probably have this. Do I have it on my slide? Maybe not. I don't know. Should have put that there, but. Oh, okay. Let me just type it in the chat, maybe just easier. Yeah, if students have any other questions, feel free to email me. This is my email. And if it's a question for graduate school, I'll tell you. A lot of the admission questions, like what the filling part of the admission process, that's all graduate school. Once you have completed your graduate application, that when your application is completed, it comes to me. That's when I see it, and then decide on the package to be admitted or not. But it has to go through the graduate school first. So if you have questions about the graduate school application, that's questions for the graduate school, because I don't know anything about that, or minimum. But if you have questions about the degree, anything related to the chemical engineering degree or anything like that related to the graduate programs, I'll be more than happy to answer your questions.
Excellent. And Molly, did you want to put your email in the chat as well, just so that if anyone had admissions questions, they'd be able to ask?
Yes, I will put my email in the chat. Most of you probably already have my email, but any questions about application, if you are missing something that needs to get uploaded, feel free to always send it to me directly and I can get that sent in for you. And then we can work through any other questions you might have.
Excellent. Okay, well, oh, I think Eugene is typing. Oh, perfect. Of course. So thank you all so much for coming to our webinar, Wednesdays, Chemical Engineering. I hope you learned a lot. And of course, these are emails if you need to reach out for any questions, if you have any concerns, or just need any assistance, we'd be happy to help you. Thank you so much for joining, and I hope you guys have a great morning, afternoon, or evening, wherever you are from. But thank you so much, and have a great rest of your day.
Thank you.
Of course. Bye-bye.